Types of transformer. Before we do the calculations, okay, so I want to show you the types of transformer. So there are two types of transformer. Step-up transformer is used to increase the potential difference. It's used to increase voltage. That's why it's called step-up. Step-up means to increase. Step-up transformer. And then we have step-down transformer. This is to reduce the potential difference. Now for step-up transformer, the secondary coil, the number of secondary coil must be more than the number of primary coil, right? Okay, because this depends on the ratio. Okay, if you want to increase the voltage, then the number of the secondary coil must be more than the number of primary coil. So because it's a step-up transformer, the voltage of the secondary circuit must be higher than the voltage of the primary circuit. Because it's step-up transformer. And the number of secondary coil must be more than the number of primary coil. Okay, more coil means more resistance. And then how about the current? Okay, current for step-up transformer, the currents of the secondary coil will be lower compared to the currents of the primary coil. So the voltage increase, but the currents decrease. Voltage increase, current decrease. For step-down transformer is the opposite. The voltage of the secondary coil is lower because step down means we reduce the voltage. So the voltage of the secondary coil is lower, and therefore the number of windings or number of coils is less than the primary coil. But the current increase. The current increase. So lower voltage, higher currents. Higher voltage, lower currents. So that is the two types of transformer that you need to know, and make sure that you really understand this because this may be asked in a test or exam. So we have example 1. I give you the formula: Vs over Ns equal to Vp over Np. Transformer is needed to convert a main 240 volt supply to 12 volt. If there are 2000 turns on the primary coil, how many turns should there be on the secondary coil? Okay, so use this formula to find the number of secondary coil. So the answer is 100. 100. Okay. So first of all, we list down those informations that we have. Let's say the supply. Okay. The input is 240 volt and the output is 12 volt. So the primary voltage 240, secondary voltage 12 volt. Okay. And the number of turns of the primary coil 2000, and we want to find the number of turns of the secondary coil, Ns. So substitute these three value into the equations and then solve the linear equations. Then you should get an answer. Ns equal to 100. So the number of coils of the secondary circuit is 100. Example 2, there are 2000 turns in the secondary coil of transformer and 500 turns in the primary coil. What will be the voltage across the secondary coil if an alternating voltage of 240 volt is applied across the primary coil? Okay. Yes, the answer is 960. So I think you should have no problem with the calculations, right? Okay, list down all the informations that we have and then plug in all these informations into the equations. Example 3, a step-up transformer has turns ratios of 1 to 100. An alternating supplies of 20 volt is connected across the primary coil. So what's the secondary voltage? Okay. So the answer is 2000 volt. 2000 volt. So the questions tell us that a step-up transformer has a turn ratios 1 to 100. Okay, so this turn ratio is the primary to the secondary coil, NP over NS. So the ratio NP over NS is 1 to 100. 1 to 100. And then the primary voltage is 20 volt. So VP 20. Okay, something wrong here. Okay, this one should be NS. NP over NS. Okay, so we have the formula. Okay, we have formula VS over NS equals to VP over NP, right? This NP multiplied to the left hand side and the VS to the right hand side, then we will have NP over NS equal to VP over VS. Okay, that's how we get this. So after that, we substitute VP equal 20, VP 20, yeah. But the ratio NP over NS is 1 to 100, 1 to 100. Solve these linear equations, then you get VS equal to 2000 watt. Example 4. So this is a multi-tapped transformer. So a transformer consists of coils of 3600 turns. So this one is 3600 turns. And another coil with a totals of 600 turns. P to T, totally 600 turns. 200, 200, 100, 100. Totally 600 turns. So this one actually you can be tapped at different various places. Okay, if you tap to a P and R, okay, then the secondary coil is 400. So it depends on where you connect. If you connect P to R, then you will have 400 coil in the secondary circuit. If you connect P to S, then you have 500. If you connect P to T, then you have 600. If you connect Q to S, then you have 300. So you can have 200, 300. So you see you can have 200, 300, or you can have 100 as well. Okay, if you connect R to S or S to T, 100, 200, 300. You can have 400s, P to R. You can have 500, P to S, or you can have 600. So it depends. It depends on what's the voltage that you want. So you can control which point you want to connect. Okay. So which pair of terminals would you connect to a 20 watt, 24 watt lamp for it to be lit normally? The input is 240 watt, but the output need to be 20 watt for it to lit normally. Okay, you must connect 20 watt, then only the power is 24 watt, which is the normal power. So which one you want to connect to get 20 watt? Which one you want to connect? PQ or QR or RS or QS? So do the calculation now. the number of windings of the secondary coil should be 300. If you want to get 20 volt, it should be 300. And 300, you can connect to Q and S. Okay, Q and S. So the answer is, okay, QS. It's just with the voltage already, you can find the answer already. 24 watt is the normal brightness. That's all. Okay. So this one is not involved in the calculation.